Hello, in our very final video for Chapter 20, Lecture 21, Learning Objective 4, we're going to talk about electrolysis and electrolytic cells and look at calculations for those. So, electrolysis, that's taking a non-spontaneous reaction and driving it by the addition of electrical energy. And it's basically the opposite of a voltaic or galvanic cell, or an electrolytic cell. So electrolytic cell is what is used to drive an electrolysis reaction. So electrolytic cell is going to be the opposite of a galvanic cell. So what you're looking for here is a E0 cell that is less than 0. So we want a negative value. So when you're trying to determine if you have an electrolytic cell, you need, or to figure out which part is your electrolytic cell, you need to write your reaction in such a way as to have it be non-spontaneous. Okay. Now, as a note, in an electrolytic cell, electrical energy is used or is converted into chemical energy. So you're making a redox reaction go in the non-spontaneous direction, so a negative E cell. Within an electrolytic cell, we've got two electrodes immersed in the same molten salt solution. So there is no trying to separate this into two cells. They're all in one cell. It's either a salt solution or in molten salt. And you're generally, in a lot of these, you're doing what's called electroplating. So you're using this electrolytic cell to produce a metal from a metal salt. Okay, so let's look at the cell over here to the right. We see that we've got molten sodium chloride, and we've got two electrodes. And if we weren't sure which direction it would go in, we have the direction written here, but if we weren't sure, we could look at our reduction potentials for chlorine and sodium. So our reduction potential of Cl2 is 1.36 volts, and our reduction potential of sodium is negative 2.71 volts. So chlorine is much more likely to be reduced than our sodium. So if we write it as chlorine being reduced, sodium being oxidized, that would be a spontaneous process. But as you see, we have the opposite process occurring. So here we have chlorine being oxidized, sodium being reduced, so this would be our non-spontaneous direction. So this oxidation would be equal to negative 1.36 volts, and then this reduction would be equal to negative 2.71 volts. So we can see very easily that the E cell here would be very negative for this. So that's why it's written in this particular direction. So basics as far as figuring out how your electrolytic cell is working, look for the non-spontaneous reaction. Okay, so beyond knowing if or how to set up an electrolysis or an electrolytic cell by looking at cell potentials, you should also be able to do quantitative analysis using electrolytic cell. So basically figuring out how much charge is needed to get a specific amount of a substance, or how much substance is produced using a specific amount of charge. So we use this flow chart over here to kind of go from charge into amount of substance in an electrolysis reaction. So we start out with the quantity of charge in coulombs, remembering that coulombs is amps times by seconds. And then from there we can use Faraday's constant to go into moles of electrons, and then from our balance equation, mole of substance that's oxidized or reduced. And then lastly we can go into grams of substance oxidized or reduced using our formula weight. So we have to have a balanced half reaction for this to determine how much substance is oxidized or reduced. Okay? So let's try out an example of this idea using this flowchart. So we've got a electrolytic cell. We want to calculate the number of grams of aluminum produced in 1 hour by electrolysis of molten aluminum chloride if we have an electrical current of 10 amps. Okay, so here we are going from quantity of charge trying to get grams. So we're going down this row. So we first need to figure out our time. So if we have 1.00 hours, remember that there is 60 minutes per hour and then 60 seconds per minute, which gives us 3,600 seconds. Then we could take that and the idea that we have 10 amps. Remember that our time times by our amps gives us coulombs. So coulombs is equal to amps times by seconds. So our amps here are 10.0 and our time is 3,600 seconds. Multiply this together, we get 3.60 times 10 to the 4 coulombs. Now using our Faraday's constant, we can convert from coulombs into moles of electrons. So we have 3.60 times 10 to the 4 coulombs. For every 1 mole of electrons, that is 96,500 coulombs, so our Faraday constant, giving us 0.373 moles of electrons. Now, we need a balanced equation for this. So, we are going from aluminum chloride into aluminum solid. Aluminum chloride, aluminum is Al3 plus. So our balanced equation would be Al3 plus 3 electrons goes to Al solid. So using that 0.373 moles of electrons, there are 3 electrons per 1 mole of aluminum produced, giving us 0.124 moles of aluminum solid. And then we can take our moles of aluminum solid, convert it into grams using our molar mass, and when we do that we get 3.36 grams of aluminum. And that is everything. Have a great day. Bye.